Hi, first grade. We're going to get started today with what do roots, stems, leaves, and flowers do? So today we're going to talk about plant parts, and I'm going to use some illustrations and a diagram to label plant parts and help us learn more about the plant parts and what they do. This story is written by Ruth Owen, and we're just going to read the first chapter. Different but the same. No one can say for sure, but scientists estimate that there are nearly 500,000 different species of plants on Earth. Some plants, such as colorful pansies, may grow just a few inches. Giant redwood trees, however, can grow higher than a 25-story building. And here they have an illustration of the giant redwood trees. Whether tiny or giant, most plants have the same parts: roots, stems, and leaves. Many types of plants also have flowers. Together, these plant parts work together to help a plant grow, stay healthy, and even produce future plants. So if we look at the photographs in the picture, we can see that some plants are very large, like the giant redwood trees, and some plants are very small, like the pansies. And then here on the diagram of the pansy, you can see the flower up here is labeled. The stem is that tall, green, thick part, and the leaves. Most of us know those vocabulary words already. Here you can see on the strawberry plant, they've labeled the plant itself, and then under the plant, which the dirt would be here underneath, you see a label for the roots. Today we're going to focus on the roots. Roots for food and water. The roots of most plants are hidden underground in soil. Some plants have many roots that spread out in the soil horizontally. Now let's think about horizontally. That word means this way. Horizontal, the horizon. Think of this way. So in my diagram, I drew the dirt horizontally. Plants grow vertically. That would be up and down. So we're going to talk about tree roots today and the roots on a carrot. A large tree may have woody roots as thick as a person's arm. Thinner, hair-like roots grow from the thick roots. Other plants have one main root that grows down into the ground. This long, thick root is called a taproot. Now I can see in the page here that the word taproot is bolded, and that's some important text information in the story. So I'm going to use that today in my diagram and label the word taproot. Dandelions and carrot plants have taproots. The orange carrots we eat are actually the thick taproots of carrot plants. So here on my diagram, I drew a picture of a carrot. And sometimes you might notice that a carrot has like little lines in it like this, and little roots that come off of it. And that large, thick orange part that we eat, that is called the taproot. So I'm going to label that in my diagram with my marker. So that's the taproot. In order to be healthy, plants need water and nutrients, such as nitrogen, potassium, and calcium. Those nutrients are important for the plant to live. They have also bolded the word nutrients in the text. So I'm going to write nutrients. And we get those nutrients from the soil. So all down here in the dirt area, the soil, is where the nutrients would be. And that is the food for the plant. They labeled them as nitrogen, potassium, and calcium. The plant's roots act like drinking straws. taking in water and nutrients which are dissolved in water from the soil. So we know that it will rain, and when it rains and the water goes down into the soil, this water will mix with the nutrients in the ground, and then the plant will use its roots to soak up those nutrients along with the water. Now this diagram is going to be a tree trunk, and I have a little trick for drawing tree trunks. I usually make two vertical lines and I put a V in the middle. Then I just extend my lines this way and this way, and I make another V, extend my lines this way and this way. Then I make another V and extend my lines to match the V, and I keep going until you can see the branches of a tree. So this one over here is going to be my example of a tree. Put some leaves here so you can see the tree diagram. And now underground, we can't see them, but there are roots growing. And in the text today, we read that many roots spread out in the soil horizontally. Horizontally, remember, means this way and this way. So the roots underground under a tree, they might look like they go straight down, and they do, a lot of them do, but then they spread out horizontally. This way, and this way, and this way. So they can really soak up a lot of water and a lot of nutrients from all around them. Let's label the trunk of the tree, because here on the page 6, they have trunk labeled as well with the roots. So we're going to put a little arrow here for trunk, and a little arrow down here for roots. Roots for stability. Now, stability means stable, not falling over, not falling to one side or another. Our feet help us stay stable when standing. Roots do more than supply a plant with water and nutrients. They also hold a plant in the soil and give stability. Stability is labeled there in dark, bold print. So we're going to write the word stability. And I want you to think about the word stability as being the feet or the anchor, the roots that hold the plant on the ground and help it not to fall over. Without roots, most plants would topple over when the wind blows, or as their branches, leaves, or flowers grow and become heavy. The roots of a large tree may spread underground in an area 2 or 3 times the diameter of the tree's branches. So they're saying that 2 or 3 times greater than the tree's actual branches is how far the roots may go underground where we can't see them. Many trees survive for years on steep slopes because their roots hold the trees steady in the soil. Here in the diagram, we can see in the caption, it says the spread of a tree roots underground. And this would be like a bird's eye view of looking down on the tree from the air. You can see how wide an area the roots spread from the tree trunk. This tree lives on a steep slope and has been blown sideways by the wind. Its roots still hold it in place. Here in this photograph, you can see the roots are exposed, and they're trying to hold that tree trunk on the slope. A dandelion is also a good example of how roots can anchor a plant in soil. Try tugging one of these little plants out of the ground, and you will likely end up with only a handful of leaves and stems. A dandelion's taproot will stay firmly underground. I actually did go outside and try to pull up a dandelion, and the same thing happened to me. I only got the leaves and the stem. It's because that taproot is so strong in the ground. I was able to find a little shoot of a plant growing with a taproot, if you can see real closely there in the photo. That's a taproot just beginning to go underground. And then I was able to pull up another weed that was growing, and you can see the hair-like roots on that plant as well. I didn't draw a dandelion plant today. I drew a carrot with the taproot. So I'm just going to show you the plant, or the green stems of the carrot growing up this way. And a carrot plant does have leaves on it as well. So just to give you an example of what that plant looks like above ground. If it was the dandelion, it would have the flower and leaves. This page is about plant stems, and so we'll stop here and continue tomorrow with more information about stems. And with that being said, I wanted to do a little experiment, and I found a flower. It's best to use either a white flower or a flower that's a light color, or you could use a celery stalk. And at the back of this book, there's an experiment where you take a celery stalk, or you could take like a white flower like I did, and with an adult's help, you can fill up a glass of water about an inch. It could only be an inch deep, or it could be deeper. But then mix 2 teaspoons of blue food coloring into the water, and then use a knife with an adult's help to cut the celery stalk or the flower. So you want to put a slit into the plant, the stem of the plant, so it can drink up like the roots would when a plant grows in the ground. And then step 4 is stand the celery stalk in the blue water, and then over the next few days, the celery stalk and leaves will turn blue, or a bluish color. Why do you think the celery stalk and leaves have turned blue? You can see here this was day 1, and then this picture was taken on day 3. And I started this experiment with my own flower, a rose, a white rose, and it is sitting in blue food coloring we had left over from Easter, dyeing Easter eggs. And on day 4, I'll show you this rose again, and we'll see how it has changed colors. And the roots act that same way, bringing the water and nutrients up through the plant, up through the trunk of the tree, or up through the taproot to help the plant grow. And remember that that water, those nutrients in the soil is food for the plant. All right, so we'll stop right there.